All right, let's do it together then. We're working on an F5 right now, finishing ionic nomenclature. Aluminum is what symbol? All right, and sulfate is what symbol? SO4. And aluminum has what oxidation state? And sulfate has what oxidation state? Hey, quit helping her. She knows this. All right, there's no reduction of charges that'll take place, so when we crisscross, aluminum's going to go ahead and get the 2. Sulfate's going to get the 3. So now we have 3 sulfates. Questions there? Let's go over to 1.5. 1.5, we're doing barium cyanide.
Ba parentheses CN 2.
Agree or disagree?
Agree.
Looks perfect. Stop me if it doesn't. Don't suffer in silence. Let's head over to cluster 6, seat 4. Aspen, where are you? I already forgot. Hey, Aspen, what did you get for tetraphosphorus decaiodide? She said P4I10. Yeah?
Yes.
Does that make anybody hungry?
Yes.
It's pie.
What?
Let's go to cluster 3, seat 4. I don't know what's happening. What did you get for calcium dichromate?
I got
CaCr2O7 is correct. Calcium is +2, dichromate's -2. There's a reduction. Questions on your ionic nomenclature?
Cards right?
I'm sorry?
Did you shuffle the cards right?
Other questions?
Okay, wait. Okay, so for dichlorate, oh, I am tripping. Okay, never mind.
Don't be tripping. So
No,
yeah.
I had totally wrote the wrong yeah. I put dichlorate.
Oh, I did dichlorate.
So I was like,
Oh, okay. All right. Are we good then?
I was like, why is it?
Okay. Go ahead and switch to your spiral out of your composition book. We're going to go ahead and finish nomenclature. We have a little bit of ionic to still look at, and then 2 other naming systems to make sure that we remember. Okay, so go ahead and go to the next. Oh yeah, perfect. You are a pro. All right, go ahead and. Oh wait, what are we doing? Are we doing this?
Yeah, it was.
Or are we doing this?
I don't like that.
All right, okay,
You
got
go
it.
for your big side.
What? All right, no, what side? Whatever. Okay,
Next one.
So you got
Yes.
that on camera.
good. What?
Did you get that on camera?
We did. People from the east side, they fear me. All right, let's let's do a first example. I want to remind you first that there is the wordy way to represent Roman numeral elements. Write that down. As your polyatomic list will point out, cobaltic is a way to write cobalt and assume a charge. What is cobaltic's charge?
3 is 3.
Yeah, we got a charge, cation of 3 there. All right. And what about thiosulfate? Do we know his formula without looking?
No.
Of course.
What is it?
S2O3 2.
All right? There's no reduction in those charges when we build the compound. So we can give those numbers. Again, your silence just indicates to me that I can keep going. And by the way, I had a... Here, y'all close your ears at home. I had a student drop last period, and they said, you're just going too fast. So realize, for those of y'all that if you feel that way, that I'm just tearing through stuff, when we hit Unit 2 and you don't recognize stuff, I will slow down some. All right, but the assumption is that you know how to do all this. So I'm just trying to remind you of all the things you already know how to do, which is attributes to the speed by which maybe I'm moving. I don't know. I don't think I'm going too fast. But anyhow, I hope no one is stressed out over this class yet.
On camera of you going, close your ears at home.
What?
You have that on camera.
Yes, I didn't pause it. What are you going to do with that?
It's right there. He's in front.
That means I won.
Okay.
Thank you.
Now, Roman numerals, of course, really show up 95% of the time for one that for any element that needs one. So you're going to see them far more often. So let's take a look at a basic common compound. Keep in mind that the only point of a Roman numeral is to indicate a charge that you wouldn't otherwise know, because the element that it's referring to can have multiple charges. So if we translate, we'll end up with iron is Fe and oxide is O. What is the charge of this iron?
3.
It's 3 plus 3, yeah, which is the only point of the Roman numeral. Your oxygen, of course, is going to be the 2. So now we can crisscross and be done. Don't say applesauce.
Spaghetti sauce.
Why don't we use that? Crisscross. Why does applesauce?
Spaghetti sauce even flows better.
It doesn't flow better. Crisscross spaghetti.
Spaghetti sauce flows.
Don't be the student that turns a Roman numeral directly into a subscript in the same position. It's less likely to see it in this class than pre-AP, but I bet there's still those of you out there that would do that. Questions? All right. Now, we want to be able to go the other direction as well. So let me give you a few examples and see if you can do it. Remember, if I give you... Hang it. That doesn't show up on the formula. It doesn't show up on the video, that color. If I give you the formula and you're writing the words for ionics, the numbers are mostly assumed, meaning that there's no prefixes. The numbers actually live within the words. So make sure that you're naming them correctly. But if you run into a species that can have multiple charges, which is your transition metals, then make sure that you indicate their charge as necessary. Take a moment and see if you can write the names for those. Let's see how you did.
I did it. I'm just kidding.
Let's go talk to cluster 3, seat 3. 3, what did you get for the first problem?
I put rubidium phosphide.
He said rubidium phosphide. You agree or disagree?
I agree.
I think it's perfect. Any questions? All right, remember "ide" is going to indicate an element that's been pulled directly from the periodic table, with the exceptions of hydroxide and cyanide. Cluster 1, seat 4. 1-4, what did you get for the second one?
Platinum arsenate.
He said platinum arsenate. Do y'all agree or disagree? What's the issue here? Platinum is a species that can have multiple charges. Therefore, we must indicate to somebody looking at our work which platinum we're talking about. What platinum is this? Platinum 2. Because that right there is the charge that originated with platinum. Yes?
We call it platinum.
You can. The only thing is, the only issue you want to be aware of on spending a lot of time in those extra words is that most of the time on the AP they're always going Roman numeral direction. But on the FRQs, if you properly do it, it's definitely still right. So. Let's head over to cluster 5, seat 2. Aspen. It is your turn. What'd you get?
I got rhodium sulfide.
He said rhodium sulfide. Agree or disagree? I disagree also. What's wrong? All right. Well, rhodium is living in your transition zone. All right. Therefore, we need to indicate what his charge is. What is rhodium's charge? It's 4. Be careful here because the 4 is not real easy to see. But what we do know is that sulfur has a charge of that 2 and it didn't show up. The only reason that would happen is if there was a reduction. And that would be the only possibility there, is that rhodium is positive 4. It'll go to 3-1, Sabrina.
Well, I would have just thrown it.
I want it.
See, I actually feel
Questions? We're feeling all right with Ionic? All right, let's switch gears. It adjusts, relax. All right, I'm sure that you already wrote down your slides before you arrived to class, so you already have this in front of you. Acidic nomenclature should ring some bells. What was the big indicator that a compound, or formula rather, that we were looking at was acidic? It started with H. So whenever we run into a compound that starts with H, we follow these rules. So let's quickly remember how we apply the rules. So let's take a look at this guy. That's aqueous HBr. What I notice is that it starts with H. Therefore, we're going to ignore the H and follow the acid rules. Br. How do we pronounce Br when it's bonded? Bromide. Came from the periodic table. So it's bromide. The suffix of that bonded element is going to indicate one of your acid rules. Ide is going to activate the top rule. And what we want to do is put the root of that word into the associated blank. And in this case, it becomes what? Hydrobromic acid. I'd like to remind you that all of your acids are going to start with H, but only one of the three rules starts with the prefix hydro. Please don't be the student that puts hydro in front of everything. Let's do another one. Oops. My bad. Again, an acid based on it starting with H. The non-H component is CO3. What's CO3? It's carbonate. Again, the suffix will activate one of our acid rules. 8. So we'll take the root and put it in the associated blank. What does it become? Carbonic. And don't forget to add the word acid. Have you seen carbonic acid in this class this year?
Yes.
Ooh, when did I show it to you?
First day.
First day. Yeah, it was one of the byproducts of when the dry ice was mixed with soap. Oh, you weren't here to see that? It was amazing. Yeah, we went on a field trip, went to Chick-fil-A.
I'm going on a Mr. Cummings binge once in
All right, let me give you a few to practice.
But we didn't do it last time.
Sorry? What did you say?
He said we need a fan club.
I did not say that. We didn't do one for the third.
Well, we will, but you've done this before.
I know, but I was absent for this lecture and don't hear more. I was absent for so many. That's why I think I was called. It's about, it's me, but.
My ear hurts bland.
Translate those to whatever format they're not in. Go to formula or name. let's head on over to cluster 6. There's nobody in cluster 6. Reynolds, what did you get? What did you get for the first one? I'm sorry. She said nitrous acid. Agree or disagree?
Agree.
Looks good to me. You can pass Aspen. Let's go to cluster 2, seat 6.
Was that me?
What'd you get for the second one?
The second one, the only one I didn't do.
Because it's an acid, it'll start with what?
Oh, let's start with H.
All right. Chromic. Before it was ick, it must have been.
It must have been hydro. Wait.
So your choices were.
Chromite.
It could have. What did you just say?
Excuse me, Chromite.
There's no chromite. Okay, so it could be hydro and ick, it could be just ick, or it could be us. This one is just ick.
Ooh, so it could also be a chromate.
Chromate. Do you know the formula for chromate is what the question becomes. He said CrO4.
didn't say that.
All right. Hey, for going this direction acidically, though, do make sure that you check charges. There is an electrostatic thing going on here. All right, so we have +1 and -2. So you've got that answer coming.
You're looking at it. Oh, there it is. It's CrO4 negative.
Let's go to cluster 6, seat 5, Aspen. What did you get for the last one there?
Hydrochloric acid?
She said hydrochloric acid. Now, HCl tends to be the acid that you know off the top of your head more commonly than the other ones for some reason, which is cool. Your stomach's full of it. But there's an issue here that might be new to your brain. Read the asterisk on the screen. You'll notice that all of the examples that we've had up to this one have been aqueous, not gaseous, because it turns out that a gaseous acid is not named acidically. So if you call it hydrochloric acid, you're wrong. What is the proper name of this then?
Hydrogen chloride.
Hydrogen chloride. So, if you did not know that rule, then make sure you make a strong mental note so you don't get tricked when it shows up on an assessment.
Mr. Cummings, could you watch a video where they actually called it hydrochloric acid?
If that's AQ, then it is hydrochloric acid. That's my point. It is hydrochloric acid if you're following the acid rules, but a gaseous compound is not named acidically. All right, and hydrochloric acid gas, all right, hydrogen chloride, is actually, it comes off the top of the stock I have back there, and I see all kinds of cool colors when that happens.
Nice.
It's super strong. Are there any questions? We have one more naming system to go over, and it's going to be one that you might be less familiar with. Organic nomenclature can be very, very challenging. If you take organic chemistry in college, the nomenclature here gets crazy. There's some really cool organic molecules that are just huge, and they differ in so many ways that naming them gets intense. Luckily for us, all we're going to care about are what are called hydrocarbons. What two elements do you think are present in hydrocarbons? Hydrogen and carbon. All right. Now, on the screen and on your slides at home, you'll notice that the prefixes associated with with organic nomenclature here are similar to covalent. Really, the only differences are the first four prefixes, because instead of going mono di tri tetra, it's going to go meth eth prop bute. That's but, not but. So you do need to know these prefixes, and I'm going to show you how to name them. Now, along the bottom, you see alkanes, alkenes, and alkynes. The suffix of those three words are the important part, and there's an associated equation. So let me show you how this all marries together if you don't know. Write this down. We'll do a couple examples together first. It's a hydrocarbon based on the elements present. I'm sorry? Is it a typo? Where? Oh, you're right. It is a typo. Yeah, can you make it pretty? No, not like that! Just kidding. That's good. Yes, no. Do what you're doing. Okay.
Wait, I messed up. I wrote that all down.
I know. I'm sorry. Now, the number of carbons is going to dictate the prefix. If that's true, what will our prefix be for this example? Prop. The suffix is going to be a question of how you get from the carbon subscript to the hydrogen subscript. And that's where the equations down at the bottom come into play. Now, what you'll notice is you always double the number of carbons. And the way I see that is it assigns carbon's number as n and H's number as always 2n. So you always double it, but then you ask yourself, do you only double it? It would be een. Do you double it and add 2? It would be ein. Or do you double it and subtract 2? It would be ein. So take a look here. If you double 3, you get 6. Well, that's not what that number is. How do you get from the 6 to the 8? Add 2. So what's the suffix? Ein.
Wait, what? What is car?
We call this the Hank Hill example.
So will it always follow those rules? Like,
Yeah, hydrocarbons always follow those rules, yes. That is the formula for propane. Let's do another one. What prefix will we have in this example? Det. Because of the number of carbons will give us that prefix. And then we want to know how we get from 10 to 18. We always double 10, so 10 doubled is 20, which is not what that number is. Then to get from 20 to 18, the suffix must be ein. This is decyne. I'm sorry? Not trying to get to anything. You're just looking at the connection between the numbers. No matter what, you always double the first number. And then if it hits that number right away by doubling it, then it's een, the middle one. But if it doesn't, it'll either be 2 up or 2 down. In this case, it's 2 below 20. And if you look at your formulas, that makes it ein. You try a few. Translate all 3 of these to whatever format they're not currently in. Let's see how you did. Cluster 4, seat 6, aspen. What did you get for the first one?
Oh, methane.
Agree or disagree? Agree. Where's methane come from?
C is 1.
Oh, yeah,
It's
C
1.
is
So we do math and then the H. 2 times N, so she goes 2 is 4.
Oh, I thought you were getting. I meant where on earth does it come from? But no, but that was a super good explanation. Yours was. What animal do we blame methane mostly on? Cows. Methane and milk. Methane and milk.
Beef and leather. What's methane milk?
What's that?
What's methane milk?
No, nothing. And
Oh.
Yeah, don't drink methane milk. That's dirty. Okay. Cluster 5, seat 2. Again. Aspen.
You realize that's me, right?
That's her.
Oh, I did not realize.
Yeah, I didn't know the last question you called me on, so I didn't say anything.
So what did you get for pentene?
C5H10.
Agree or disagree?
agree.
I agree. Cluster 6, seat 3, aspen. You get your chance in the sun, anyways. You put what?
Ethane.
Ethane. Spell the end of it,
Okay.
just in case you got it right but are saying it wrong.
YNG.
Ethine.
Oh, okay.
Everybody doing all right?
Yeah.
We're going to switch gears a little bit tomorrow and go to the mole concept, molar mass, and stuff like that.
No,